Hi friends, exercise 2.7 complex number system. Third question, if x1 plus I y1 into x2 plus I y2 x3 plus I y3 dot 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 xn plus I yn equal to a plus ib. Show the result. If you take modulus, it is easy to prove the result. So we have a formula, okay, z1 z2, okay, modulus of the product equal to product of the moduli, modulus of z1 modulus of z2. So using this result we can take modulus for the first result. The given, what is your given? Take modulus x1 plus I y1, okay, and x2 plus I y2 and x3 plus I y3 dot 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 xn plus I yn, and right side we have a plus ib. Take modulus on both sides. When you take modulus, whole modulus, if you take whole modulus on both sides, what will become? As per the formula, a modulus of the product. We can take modulus, individual modulus we can take. So the whole modulus we can take into individual modulus. Each and every term modulus. We are taking modulus for each and every term. So what is the formula for modulus? If you have x plus iy, what is the modulus value? Modulus becomes square root of x square plus y square. This is your formula. Okay. Now if you square on both sides, x plus iy whole square, modulus square, equal to the square root will cancel. We can get x square plus y square only. Like that, now square on both sides. If you square on both sides means every term will be square. Square on both sides means each and every term will be square. When you do each and every term square, we can get the first result. What is the first result? x1 square plus y1 square, x2 square plus y2 square, x3 square plus y3 square, dot dot xn square plus yn square, which is equal to a square plus b square. Understand, dear students? And what about the second problem? Second problem is nothing but angle. We are going to talk about angle of the tan inverse yr by xr. They are adding the angle of all the terms you have to add. So how to add the angles? You have to use the polar format. To use the polar format, we can do the second problem. So let me do the second problem. We have space above the question. Now take angle. So we have a formula for angle. Okay, what is the letter Z1? Z1 equal to R1 into cos theta 1 plus I sin theta 1. We take like that. So which is nothing but x1 plus I y1. Take like that Z1. And what is Z2? Z2 equal to R2 cos theta 2 plus I sin theta 2 x2 plus I y2, like that. Now we have a formula. What is the formula? Argument of Z1 into Z2. Argument of Z1 plus into Z2 equal to argument of Z1 plus argument of Z2. This is your formula. So what is argument of Z1 and Z2? If you take that multiplication, product of Z1, Z2 is nothing but R1, R2, and we are going to write single cos theta 1 plus theta 2, okay, plus I sin theta 1 plus theta 2, okay. This is your product formula. So what is the argument? Theta 1 plus theta 2. Here theta 1 plus theta 2 is the argument of Z1 into Z2. That's why we got this formula like that. Now we are going to find the Zn. Up to Zn we are going to find the argument. So what is your argument of Z1, Z2, Z3, dot 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 Zn. What is your argument? It is nothing but theta 1 plus theta 2 plus dot 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 plus theta n. This is your formula. Summation of theta 1. What is your summation of theta 1? Okay, this theta 1, if you ask, this is polar format. When you talk about Cartesian format, here theta 1. Argument of theta 1 is what? Okay, theta 1 is your argument of Z1, which is nothing but tan inverse of imaginary part, which is y1 by x1. Imaginary part is y1 by x1. This is your angle formula. There are two formats. To find the polar format, theta 1 is the angle, and Cartesian method, tan inverse of y1 by x1. So we can change all the terms. What? Tan inverse of y1 by x1 plus tan inverse of y2 by x2 for second term. Next, tan inverse of y3 by x3 plus dot 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 the last theta n. Theta n nothing but tan inverse of yn by xn. So this can be written as sum of, you can write sum of tan inverse of what? Y some r by x r, where r equal to 1 to n. Where r equal to 1 to n. So like that we can write. Plus it is the rotation property. We can write what? Right hand side. Now come to right hand side. This is your left hand side. What is your right hand side? See the given result. Right hand side we have a plus ib. So for a plus ib, what is your angle? We find the argument of a plus ib. A plus ib argument. How to find the argument of a plus ib? Which is equal to tan inverse of b by a. Imaginary part by real part. So using that formula, we can bring the right hand side. What is your right hand side? A plus ib. So when you are using a plus ib, okay, with the common rotation 2k pi, where all k belongs to Z. This is your RHS. So LHS is the argument of terms which is nothing but sigma r1 to n tan inverse of y by r. So both are equal because the argument of the product of the complex number equal to sum of the arguments. Using that formula we are writing it. Understand, dear students? Argument of product of the formulas equal to sum of the arguments. Argument of the product of the complex number equal to sum of the argument. Using that formula, we can prove the second result. Understand, dear students? Is that doubt, sir?